Welcome everybody to the fifth webinar of the Biohacker Experiment. My name is Andrew Ramirez. I'm a Bachelor in Health Science, Human Nutrition and Dietetics with honors in exercise and performance. And today I'm going to be talking about exercise and health. The four main pillars of health are understanding our genetics, nutrition and supplementation, our lifestyle like sleep, smoking habits, mental health, and exercise. And what I'm hoping to teach you guys today is why exercise is such a fundamental aspect of overall health. So to start my talk, I want to explain to you guys what I'm going to be talking about today. I'm going to be explaining the physiological meaning of exercise, how exercise influences disease prevention, how it also modifies people's mental health, how it has an impact on sleep quality, longevity, and I'm going to finish by giving you guys some workout recommendations. So what is physical activity? Physical activity can be defined as bodily movement produced by skeletal muscles that result in energy expenditure. But in my personal opinion, this definition falls short because it's missing a fundamental aspect of exercise, which is how it influences homeostasis. So homeostasis is the body's ability to maintain internal stability while adjusting to changing external and internal conditions. So what does this mean? That means that the body constantly tries to keep its own internal systems in balance. And balance can be temperature-wise, chemistry-wise, etc., etc. So an easy example would be, if our internal body temperature increases, we start sweating to lower the temperature, right? If our body temperature decreases, we start shaking, we start activating our metabolism to try and warm up again. So the body constantly tries to maintain a balance. So in this sense, physical activity challenges the body's homeostasis, okay? It's a stressor, a healthy stressor, and it activates the protective mechanisms that result in a beneficial adaptation that promotes or ensures health. So in other words, exercise gives us a healthy stress that will force our body to activate its protective mechanisms that will strengthen our system and strengthen our overall body and will better enable us to ensure health and fight disease. So how does our body respond to physical activity? There's two different types of responses. There's a short-term response and then there's a long-term response. The short-term response tries to counteract the immediate conditions that physical activity puts on our body, right? To mediate the healthy stress. And that will be increase our sweating rate. So we sweat more in order to get rid of the excess heat that's produced in our body. It will increase our blood flow to both our muscles and our skin. In our skin, it will be to dissipate properly the heat that's extra produced in our body. And to our muscles, it will be to give them and provide them oxygen, other nutrients, and help them get rid of carbon dioxide and other unwanted molecules that are a consequence of increased metabolism. Our body will also increase its cardiac output, so we will be pumping more blood all around the body, and our heart rate will increase. Our breathing rate will also increase in order to, as I said, provide all the oxygen as we can to the body and get rid of the excess carbon dioxide. And our catabolic metabolism will also rise. Catabolic metabolism is the breakdown of molecules, mainly fats and carbohydrates, to produce energy. Protein is also catabolized a little bit, but not in big amounts. And to understand the long-term response to exercise, we first need to know which different types of exercise there is. There's anaerobic exercise, and then there's aerobic exercise. Anaerobic exercise is exercise that is characterized by having a need of a big amount of energy in a short period of time. So they can be, for example, sprints, jumping, weight training. And like I said, they require a big amount of explosive energy. And unfortunately, our body doesn't have a mechanism to provide oxygen quick enough to our muscles in order to fulfill these quick energy needs. So for that, our body has two different metabolic pathways. breaking down phosphocreatine. So we take the ATP molecule and we rip it away from the creatine in order to get a quick amount of ATP chemical energy. And lactic acid glycolysis. Lactic acid glycolysis is breaking down a glucose molecule in the absence of oxygen into two lactic acid molecules. Now, the upside of these two metabolic pathways is that it provides a lot of energy. The downside is that we cannot do it in a prolonged period of time. So we don't have that many phosphocreatine levels in our muscles. And when we engage in a lot of lactic acid glycolysis, lactic acid accumulates in our muscles and lowers our pH. That's where we get our feeling of burning and sensation when we're sprinting for more than a minute and a half straight, right? Our body cannot get rid of the lactic acid quick enough as we produce it in very high amounts. Aerobic exercise, on the other hand, we are able to provide oxygen quick enough to our cells, to our muscle cells, to produce energy through cellular respiration. Now, that being said, we can engage in aerobic exercise for a long period of time, right? We can cycle for 5 hours. We can go for 2-hour walks. If we're pretty fit, we can run for about a whole hour. It really, the amount of exercise we're capable of doing will depend on how much in shape we are, how much our body systems have adapted to our physical exercise. But the downside of this type of exercise is that we aren't able to produce explosive energy, right? It's a slow, moderate amount of energy in a prolonged period of time. That being said, what happens in our muscles is we increase cellular respiration. That sort of metabolic pathway will break down glucose, either as the isolated molecule or in the form of breaking down glycogen, which is the polymer of glucose, and fatty acids. So we oxidize them in our mitochondria and we produce a lot of energy. Downside is that it requires time and it requires oxygen. That is why we cannot provide it that quickly. So now that we know this, the long-term physiological adaptations to exercise will mainly be 4. So in our musculoskeletal system, we both increase the number of mitochondria and the size of our mitochondria. If we perform physical activity for a prolonged period of time, our body, in order to meet the high demands of energy, will have to increase its production of the powerhouse of cells, right? Mitochondria. Our oxidative enzymes will also increase, and the metabolic flexibility of our mitochondria will also change. So a mitochondria can, like I said, oxidize both glucose and fats. So the more in shape we get, the better we are at using fat as energy. So the more efficient we get at burning different substrates, depending on what sort of energy demand there is. So that being said, the more in shape we are, the more fat we burn in one same workout. So very interesting. We also increase our myoglobin production. Myoglobin is a protein in our muscles that stores oxygen. And we also increase our capacity to store glycogen in our muscles, like I said, the polymer of glucose, and we increase bone density and strength. Now, it's mostly physical exercise that involves impact, that creates micro tears in our bones that will, in the long term, increase the amount of calcium that we deposit into our bones in order to strengthen them, okay? So like I said, in the musculoskeletal system, we increase our ability to provide energy, burn fat, provide oxygen, and get stronger bones and, of course, muscles. In our respiratory system, we increase our alveolar diffusion. So alveoles are the smallest functional unit in our lungs. And it is where gas exchange produces in between our blood and the air we breathe. So we absorb oxygen and release carbon dioxide. The upside of this is our ventilation rate increases. It can increase up to double the amount if we compare a person who is sedentary and doesn't perform any exercise and a person who's physically active. Their ventilation rate, their ability to inhale and exhale air will even double. And lastly, in our cardiovascular system, we will increase the end diastolic volume, so the amount of blood that we're able to pump out from our heart, our stroke volume. We will also get thicker and stronger myocardial walls, so the muscles in our heart will also get stronger, and our heart will also face less peripheral resistance. That is, that it will be able to pump the blood around the body with a lot more ease, right? Thanks to the lowering of blood pressure that exercise induces in our body long term. So all in all, we do get a lot stronger heart, and we are more easily capable of pumping blood all around the body. Lastly, the antioxidant defense mechanisms in our body increases a lot. And this has a major effect on our health, on our body's ability to defend against toxic molecules that are produced in our mitochondria. So long-term exercise has proven to increase the secretion of superoxide dismutase, catalase, and glutathione peroxidase, 3 enzymatic antioxidants that are essential in keeping our cells young, healthy, and strong. The 2 major muscle fibers are slow twitch and fast twitch. Slow twitch muscle fibers do really well in aerobic exercise, endurance exercise, what we call cardio. They are very good at producing oxidative or energy through oxidative metabolic pathways, so burning fats and glucose in their mitochondria in order to produce a sustainable amount of energy in a long period of time. That's why they are very resistant to fatigue, and they have a lot of mitochondrial density. The downside is that they cannot produce a lot of energy in a short period of time. So their contraction time is pretty slow. On the other hand, our fast twitch muscle fibers, especially the type B, they are capable of producing a lot of energy in a short amount of time, right? So they produce a lot of power. They have pretty big muscle fibers. That's why the people that perform in aerobic intense exercise, sprinting, javelin throw, gym training, they appear to have very big muscles because of how large, the motor neurons in fast twitch muscle fibers are. And they have a high glycolytic capacity. So they are able to produce energy through anaerobic glycolysis very quick. The downside is that they're very prone to fatigue. They burn out pretty easily. They have little amount of mitochondria, and they're not very good at oxidizing fats and carbohydrates to produce energy, in a long period of time. Now, fast twitch A is a muscle fiber that's kind of in between in both. And as we will see later, depending on what sort of exercise that you perform, your fast twitch A muscles can shift to either fast twitch B or remain in fast twitch A, depending if you cycle more and engage more in cardio, or if you engage more in physical training and power exercise. So how do we actually improve our body system, right? Like I said, exercise is a stressor, is a healthy stressor that forces our body to strengthen, to improve its systems, to become more efficient. And the reality is that this doesn't happen while we're training. This happens while we're recovering. There's a very nice saying which I like, which is training gets you tired and recovery trains you. But sometimes we do not recover properly from exercise. This might be because we don't sleep enough, we don't eat properly, or we overlap our workouts too soon. So we don't allow our body to engage in all the recovery processes that it needs to in order to get in shape and better recover from the exercise. So in this case, this cyclist did his first workout, then before it had time to recover, did a second one, then a third, and then it recovered for a long period of time. The fitness gain from this cyclist is a lot less than we saw from the previous cyclist, and they were all 3 workouts. Only problem is this cyclist didn't allow his body to recover in time. Now, when this happens, especially in elite athletes in a long period of time, they can suffer something called overtraining syndrome. Now, overtraining syndrome can occur if, for example, after the 3rd workout of this cyclist, the recovery wasn't long enough in order to regain its initial basic fitness level, and it worked out again. If that happens, we can lower our fitness level, actually, and it will manifest through different symptoms, which can be overall unexplained fatigue, a lot of muscle soreness and stiffness, a weakened immune system, increase in infections as a result, some insomnia, having trouble sleeping, trouble concentrating, unexplained weight loss. If there can even be some heartbeat irregularities, and then some psychological symptoms like lack of motivation, depression, or irritability. So recovery is essential for us in order to get all the benefits from physical exercise. Now, our immune system is a wonderful system that gives us so many health benefits, and it literally does everything it can to protect our bodies as much as it can, right? The 3 main pillars of the immune system are it protects against invasions, against infections, right? Bacteria, viruses, or parasites. It regulates inflammation in our body, which is very important to recover our tissues, our cells, protect our organisms, right? Our bodies or our different systems from different sort of stresses. And it also serves as a regulator, and it attacks and kills cancerous cells and cancerous activity. And about 20 years ago, this very novel study came out where it was proven that moderate to high physical exercise actually boosts your immune system, right? It increases the strength of your immune system, and they have a better capacity to resist to infections and other diseases than people who do not perform any sort of exercise. What does this mean exactly? It will improve the efficiency of your vaccinations, right, and your antibody production. It will reduce low chronic inflammation. This has been seen in many different studies. And it will improve your immunological biomarkers. So all in all, physical exercise will take away your old and damaged lymphocytes, and it will force your body to create and renew your lymphocyte storage. So in a way, it will rejuvenate your immune system and boost it. So now we can get a better overview of how exercise will strengthen our body, strengthen all our systems to better fight disease and aging when when we are faced with it, right? The 4.5 major aspects of disease prevention induced by exercise are in our cardiovascular health, in our metabolic health, in our bone health, and in our central nervous system health, right? It will help prevent neurodegenerative disorders. So regarding our cardiovascular health, physical activity done in a long period of time will decrease our heart rate because our heart will get a lot stronger, and we won't need to pump blood as many times or that quick in order to get blood through all our body into our cells. It will improve the cardiac hypertrophy, make us get a stronger heart. It will decrease the blood pressure, and it will improve our lipoprotein profile. So it will lower our LDL, bad cholesterol, improve our HDL, good cholesterol, and overall lower our cholesterol levels. So what is the impact of this? What is the outcome of all of this? People who are in shape will have considerably lower risks of getting heart attacks, thrombosis, atherosclerosis, right? All these cardiovascular diseases that can be very life-threatening for a lot of people are considerably lower in people that are in shape. Regarding our metabolic syndrome, because we're constantly in a stress scenario, a healthy stress scenario induced by exercise, where we have to provide big amount of energy, on a regular basis. If we exercise every day, we will better improve our insulin sensitivity, which is really good. We will respond a lot better to high levels of glucose in our blood, especially after eating. We will improve, like I said before, our cholesterol profile. We will increase the amount of mitochondria that we have, so we will better improve our mitochondrial efficiency and flexibility, because we will be better able to burn fat in order to get energy. And of course, we will lower our body mass index and our obesity rates. People who perform physical exercise physical activity rates of obesity are extremely low. And it's because we're constantly put in this healthy stress environment where we need to provide energy to our muscles. And we of course use fat in order to meet those demands. So our obesity level and our visceral fat obesity will be a lot lower. So exercise is extremely protective for diabetes type 2, and it is even used as a prescription in order to get rid of diabetes type 2. Regarding bone health, like I mentioned before, physical activity that involves impact, weight training, running, for example, not so much swimming or cycling, will improve our bone density, the amount of calcium that is deposited in our bones. It will increase our muscular strength, our joint flexibility, and our balance and coordination. Now, this has a lot of impact, especially at our later stages in life, because if we have stronger muscles, if we have better coordination and balance, we will prevent ourselves from falling down and potentially breaking a hip or breaking another bone, which, let's face it, when we are about 80 or 90 years old, it can cause quite a level of discapacity. Exercise, what it does is it will prevent that from happening to a certain extent, and it will also increase the health of our bones. Now, very interestingly, if we perform physical activity on a regular basis, at age 70 something, it has been proven that we will be able to have as healthy bones as 40 or 30 year olds that do not perform any sort of physical exercise. Now, just imagine the impact that exercise will have on our bone health, on decreasing the chances of getting osteoporosis, for example, atherosclerosis, if we stay in shape throughout our lives, especially in our later stages in life. Lastly, I think it's just absolutely fascinating how physical activity decreases our risk of developing neurodegenerative disorders. Now, what will exercise do? It will lower our neuronal dysfunction. It will increase our cognitive performance, and it will lower considerably our chances of getting Alzheimer's and Parkinson's. Now, how does it do that? Well, of course, it's still under study, all the physiological mechanisms, but it's been proven that exercise increases the levels of your brain-derived neurotrophic factor, which has been very protective for Alzheimer's disease. It will reduce the inflammation in the central nervous system. It will induce something called angiogenesis in our brain. Angiogenesis is a development of new blood vessels, so it will improve blood circulation in our brain. It will lower the levels of something called amyloid B peptide, which has been strongly linked to Alzheimer's disease. It will prevent and protect dopaminergic neurons. Dopamine is a neurotransmitter that is very much related to motivation, sensation of well-being, and memory. And the exercise will also decrease the level of a protein called alpha synuclein, complicated name, and which has been linked to the development of Parkinson's disease. Now, just as a little snippet here, exercise also has quite an impact on the development of cancer. So it has been proven to be very protective in that aspect. And just to give you an example, there was a study that came out in 2013, which showed that a novel myokine, which I'll explain what it is in a second, called SPARC, helped prevent the development of tumors in your colon. What exercise has proven many times in scientific studies is that regular, moderate to intense exercise, about 30 to 45 minutes, improves your sleep quality, improves how many hours you get to sleep. It reduces your midnight awakenings, and it makes it easier for you to fall asleep. We've seen that a lot in insomnia patients, in patients with sleep apnea, and in other patients that have a lot of trouble sleeping. It actually reduces, for example, their anxiety before going to sleep. It alleviates their symptoms, right? Obstructive sleep apnea is a condition in which your muscles in your respiratory tract, they will relax while you're sleeping. So they will get a little bit smaller, and you will start snoring a lot and then have a lower oxygen intake, maybe wake up in the middle of the night. And the symptoms are, of course, feeling very restless in the morning and having very disruptive sleep habits. Now, interestingly enough, working out in the morning will actually reinforce your natural circadian rhythms, right? As we know, cortisol is increased in the morning, and later during the evening, they are at its lowest levels to help us relax and fall asleep. So when we do physical activity, we help our body produce the amount of cortisol that it needs, right? Because cortisol is induced during physical exercise because we've got high energy demands. And in turn, it will help lower it at the end of the day. So actually working out in the morning has been shown to some people better get a good circadian rhythm, better get a good daily habit. The downside is that doing very intense physical exercise late at night, so 1 to 2 or 3 hours before going to sleep, have actually shown a negative impact on your performance, on your sleep performance. Now, this is mostly seen in elite athletes who perform very, very hard, strenuous exercise late in the evening. And a theory behind this is because exercise with this sort of caliber exercise increases your body temperature quite a bit, and it takes a while for your body to go down to its basal levels. Naturally, in our circadian rhythms, our body temperature decreases at the end of the day, so it's easier for us to fall asleep if our body temperature is quite low. Interestingly enough, athletes, especially cyclists or swimmers, who take ice baths in the evening right after very late training will sleep a lot better. Now, this doesn't mean that if we do exercise late in the evening, we can't get good sleep quality. There's actually quite a lot of people, especially me, who really like to work out at the end of the day. And I sleep very well. It all depends on the intensity and how long you do physical exercise. Of course, if you run a marathon at 7 o'clock at night and you finish at 9:30, you have dinner, stretch, go to sleep. It's going to take a while for your body to just relax and calm down and engage in sleep. But if it's just a 35-minute run in the evening, there should be absolutely no problem. Another aspect of exercise and health is how it influences our mental health and how it lowers our stress. So it has been very well proven that exercise reduces anxiety, depression, and ADHD. It also really helps people deal with some sort of mental health complications like PTSD or bipolar disorders. Now, how does it do this? It improves your hypothalamic pituitary adrenal axis, which we know ends in cortisol production. It's been proven, especially in late stages in life, that either extremely high levels of cortisol or low levels of cortisol can lead to mental anxiety and depression. So exercise helps regulate this whole axis and have more stability, hormonal production in this aspect. As we've seen before, exercise also improves your cognitive function, and as well just helps you get distracted from everyday stresses. It increases your self-efficacy and your confidence. After you've managed to finish a workout, you get quite a boost of confidence, and it increases your energy and your stamina. Now, at a physiological level, I found it particularly interesting that exercise increases the secretion of some endorphins, which are strictly linked to a feeling of pleasure, of overall well-being and satisfaction. Also, exercise will improve not only your mitochondrial function and number in your muscles, but also in your central nervous system. So there's a thing called neuroplasticity. Neuroplasticity is a term that describes our neurons in our brain's ability to learn and to change certain neuronal connections, right? Adapt to different trains of thought, different that might happen from different environments. Our ability to learn and to respond to certain mental stresses. Through exercise, we will be able to have a lot more mitochondria in our neurons that will provide enough energy that is needed to engage in neuroplasticity. And that has quite an effect on mental health. Now, there was a study that came out in 2019, which concluded that exercise increases some neurotransmitter levels in the brain, serotonin, one of them, that have the same effect as antidepressive drugs. So exercise, regular routine, moderate to intense exercise, has actually proven to be a sort of medication for people with depression, with anxiety. So it has a tremendous impact, not only in our physical health, but our mental health as well. About 20 years ago, it was discovered that muscles secrete these tiny peptides called myokines. And myokines have quite an impact on our body function in our system. They regulate quite a lot of our functions. Back then, there was only a handful. Now, 20 years later, there's more than 600 known myokines that have different activities throughout the body. When we perform physical activity, these myokines are secreted into our bloodstream. Some of them are, for example, brain-derived neurotrophic factor, which, as we've seen already, has great impact on our mental health and the prevention of Alzheimer's disease. Others, for example, like Spark, had an impact on the development of bad cancer cells. They were very protective in that aspect. But mostly these myokines have a great impact on our health because it increases our metabolism, it increases our metabolic flexibility, right? Our ability to burn fat instead of glucose. It increases our muscle mass. It makes our body get more mitochondria. And interestingly enough, it will decrease autophagy, right? Cell recycling in our muscles, but it will increase it at a systematic level, right? So, and it will intervene in cellular rejuvenation and delayed aging. I'll speak a little bit more about that in a minute. But it's a shame when people, when they grow older, they actually start doing less exercise. Because as we age, and when we enter our late 60s, 70s, 80s, our body's ability to gain muscle decreases, and our muscle mass also decreases. So we have the impact of that on our health is tremendous. There's so many aspects of our health that are affected, and we're so much more predisposed to get diseases, especially chronic diseases, because of this. Now, this is called sarcopenia, and like I said, is defined as the gradual loss of muscle mass, which is thought to actually be attributed to several factors such as chronic inflammation or oxidative stress, but most importantly, physical inactivity and an imbalance of protein homeostasis, and therefore overall aging. So it is very key at later stages in life to keep our muscle mass, do exercise to have healthy muscles so our muscles can help the rest of our systems through these myokines to maintain metabolism, stay strong, increase blood flow, have more mitochondria, all these numerous health benefits that it will have on our body to make it a lot stronger and prevent disease. So that being said, exercise has such an impact on our longevity, and it's actually proven many times that it decelerates our aging process. So we know that aging at this point is not linear, right? Thanks to our last talk by Dr. X. Aging is not a linear process. It can be slowed down or accelerated. What does exercise do? It slows it down. How does it do that? It induces non-muscular autophagy. You know, there was in 2016, this researcher called Yoshinori Osumi got this Nobel Prize because he was better able to describe the mechanisms that are involved in cellular autophagy. Cellular autophagy is cellular recycling, rejuvenation. You break down the parts of your cells that aren't functioning properly and you replace them with new parts. And what you get in the end is a recycled cell that functions a lot better. What happens when you function a lot better? You better fight disease, better fight stresses, and you decelerate aging. So exercise induces non-muscular autophagy. It also actually increases telomerase activity and telomere length. As we know, in the end of our chromosomes in our DNA, we have these parts called telomeres. As we age, as our cells have been replicated for a long number of times, the end part of our chromosomes, these telomeres, they start shortening and shortening and shortening. That has quite a big impact on aging, and it actually describes cellular aging. Exercise has proven to increase the telomerase activity, the enzyme that rebuilds telomeres, and increase or slow down the loss of telomeres in immune systems and in stem cells around our body. Now, what impact does this have? Well, it increases our immune system's activity at a healthy way, right? It boosts it, it rejuvenates our immune system, and it will better fight disease, reduce chronic inflammation, and fight cancerous activity. Exercise also increases myosatellite cells, which are stem cells in our muscles that are differentiated into cells when we do exercise and our muscle fibers tear a little bit. So we need to build new muscle fibers, we need to rejuvenate cells, and therefore build muscle, right? So exercise helps us rejuvenate not only cells in our body through autophagy, but also muscle fibers. So we get younger muscles, which I think we all want at later stages in life. Exercise also balances serotonin levels, which excessively high or low levels at later stage in life has been linked to depression at early ages, right? When we're 80, 90, we're very predisposed to get depression because of life circumstances, but also because of physiological factors such as serotonin levels. So exercise helps balance that serotonin and therefore prevent depression in old age. Interestingly enough, our ability to fight antioxidants improves when we're in shape. So if we've managed to maintain good physical shape through regular exercise throughout our life, our body's mechanisms to fight antioxidants and protect ourselves is a lot higher than if we did nothing, than if we did no physical exercise. And this has such an impact on health. As we know, we can influence how quick we age through epigenetic influence in our genes and our gene expression. And antioxidant activity has such a detrimental effect on our cells, and it accelerates aging so much. So improving our body's ability to fight oxidants has a tremendous impact. Another gene that is very spoken about in longevity, if you guys have heard about David Sinclair and his book Lifespan, you might have also heard his podcast Lifespan, which is Spotify, which I really recommend that you guys listen to. He speaks a lot about mTOR. David Sinclair is a researcher who has a lab in Harvard, and he focuses on longevity. mTOR is a protein that when it has been lowered, it has been proven that it promotes healthy aging and delays aging, right? It helps us live longer. What happens in exercise in relation to mTOR is that there's a big demand of energy, as I said before. And when there's a sense of lack of energy and our body needs to get activated and engage in oxidative cellular oxidation and anaerobic glycolysis, there's a gene expressed called AMPK. AMPK suppresses mTOR, and suppression of mTOR has been strongly linked to healthy aging and longevity because it intervenes in controlled autophagy, right, the recycling of cells. It improves mitochondrial function by replacing all these mitochondrial parts which are not functioning properly, and it helps regulate cellular senescence, right, cellular aging at a systemic level. Of course, as you might have heard before in our talk of longevity given by Dr. X, mTOR is also suppressed with fasting and with lower protein intake in your diet. But mTOR is also very necessary to build muscle. So mTOR doesn't need to be, of course, overexpressed or underexpressed. There needs to be a proper balance, and we achieve that balance through exercise. So if we engage in cardio exercise, we will lower its levels, and then we will have all these health benefits. If we increase our levels through proper eating and through physical training exercise, we will also get all the benefits from mTOR, which are muscle hypertrophy and all the other health benefits that has. So there needs to be a proper balance of suppressing mTOR and expressing mTOR, and we get that through regular, moderate to intense exercise. Now, I really like this quote, which is skeletal muscle and strength is strongly linked to the extension of lifespan in an increasingly sedentary lifestyle in modern society. So if there's one thing that I would like you guys to take from this talk, is that don't fall in the trap of a sedentary lifestyle. Our bodies were made to exercise. It has such a beneficial impact to our health. There is no one single nutrient, there's no one single medical intervention that has such an impact on health as physical activity and exercise. In our cardiovascular system, in our mitochondrial and cellular level, in aging, in our mental health, in our mood, in the prevention of cancer. It's just such a fundamental pillar in health. And I hope you guys really take that in after this talk. So I would like to finish it by giving you guys some recommendations on physical exercise, physical activity. There is no one size fits all, right? We cannot all engage in the same physical activity plan. One thing it is true is that strenuous exercise is pretty detrimental to untrained individuals. So if you're out of shape, if you haven't done exercise for a while, and you suddenly engage in a very hard workout plan, your body's going to suffer quite a bit because you don't have the physiological adaptations to handle that stress, right? To handle that sort of healthy stress. You won't be able to fight the reactive oxygen substances that are produced. You won't be able to restructure your muscle fibers that have been broken down, or your bone micro tears. So my recommendation would be for you guys, if you haven't done exercise for a long time and you're out of shape, to slowly engage in workout plans, right? Start slow, build your body to it, get your body and your immune system and all your other systems a lot stronger, and recover properly, get better, and then fully engage then in a workout plan. Now, you guys took DNA active test, and it's such a great test to adapt your workout plan. So look at your recovery recommendations. If you have a high risk, then try not to put 2 workouts in one same day, and then try and have about 24 hours of rest in between your workouts, and then maybe do 4 to 5 workouts a week, where you give 1 day's rest in between the second and the third day. Look at your training program predisposition, right, and your DNA active. See if you are more prone to respond better to endurance training or into strength training, and look at your peak training time. Of course, this is hard to say because we all have different schedules. Sometimes we work in the morning, we have to do all these things in the afternoon. It's hard to find, an ideal time to work out. So look at your peak training time. If you are more predisposed to get benefits in the morning, then try and fit your schedule to work out in the morning. If you actually really don't like to do that, put in the afternoon, in the middle of the day. Figure out what works best for you. So my recommendation in this aspect would be, you could either, if you really just like walking, engage in 5 30-minute walks a week. This can also be do 2 runs that are 75 minutes long, which is quite a long run. Or you can divide it into 3 or 4 runs of about 30 minutes, so 40 minutes. I think that's a lot more viable. Or you could mix them both. I think this would be more ideal, right? Imagine you go running Monday and Thursday, and then you walk Tuesday, Wednesday, Fridays, for example, and then or a stroll on a Saturday or something like that. But the most important recommendation here would be to overlap these cardio trainings with muscle strengthening activities. I've spoken about before, maintaining proper muscle mass is so important in the late stages of life for disease prevention. So the best way to do that is to engage in muscle strengthening activities. You can do that through Pilates, regular strength training. You can do it through HIIT training. You can do it through different hot yoga activities. I would really recommend that you sign up for one of these courses, try out which one you like the most, and then of course enjoy it. I mean, physical activity is not something that we need to do. It's something that we should do, and we should enjoy it, which is the most important thing of all, right? We're supposed to love and have fun in this whole health journey that we're going through. So I want to thank you guys for listening to my talk today. I hope you guys got a better overview of what exercise does to our body at a physiological level and at a mental level as well, why it is such an important and fundamental aspect of our health. And of course, I hope you took some great knowledge with you and some great advice that you are able to take home with you and incorporate into your health plan. Thank you very much. My name is Andrew Ramirez, and if you have any questions, always feel free to text me, email me. You guys have my contact number. I wish you guys a great week and all the best. Bye.